Good morning, everybody. Today, at the lecture, we will discuss an important and interesting topic that concerns the application of our knowledge of physics in medicine. Directly, namely, we will study today the device of medical equipment for the diagnosis of various diseases. Today, we will be studying medical electronics. Of course, physics, like any other science, developed and develops in connection with the needs of society. Its progress is stimulated by practical problems. In turn, the development of physics contributes to the solution of practical, including technical, problems. So, for examples, as a result of advances in the field of research of electromagnetic phenomena, the corresponding branches of technology have been rapidly developing. Electrical engineering and radio engineering. Gradually, many sections of radio engineering began to be called radio electronics or electronics. But what does the term electronics itself mean? The term electronics, how can you see on the slide, is largely conditional. It's difficult to give it a clear definition. It's most correct to understand electronics as the field of science and technology in which the work and application of electrovacuum, ionic and semiconductor devices are considered. In general, electronics in the broadest sense of the word, you can say general electronics, can be subdivided into groups either according to the field of application or according to the class of devices used or according to the category of theoretical issues. This is how physical electronics is distinguished, meaning the branch of physics that considers the electrical conductivity of bodies, contact and thermoionic phenomena. Technical electronics means those section of it that describes the devices and their switching circuits. Semiconductor electronics is what refers to the use of semiconductor devices and etc. Sometimes all electronics are divided into three large areas. Vacuum electronics, what is this? Which covers the creation and use of vacuum devices, for example, electronic lamps, photoelectronic devices, X-ray tubes, gas discharge devices. Second type is solid state electronics, which covers the creation and use of semiconductor devices, including integrated circuits, quantum electronics is a specific branch of electronics related to lasers and masers. All these examples, on the one hand, give an idea of the content of electronics. On the other hand, once again, note the uncertainty of its boundaries. Electronics is an applied branch of knowledge. All this is, of course, important, but we are still closer to the medical use of electronics. One of the common uses for electronic devices is in the diagnosis and treatment of diseases. Sections of electronics in which the features of the use of electronic system for solving biomedical problems, as well as the device of the corresponding equipment, are considered are called medical electronics. What is about medical electronics? You can see the definition on the slide. Medical electronics is based on information from physics, mathematics, engineering, medicine, biology, physiology, and other sciences It includes biological and physiological electronics. So, the applications of electronics in medicine are manifold because it's an even expanding field. Currently, many traditionally non-electrical characteristics, like as temperature, body displacement, biochemical parameters, etc., are converted into an electrical signal during measurement. The information provided by the electrical signal can be conveniently transmitted over a distance and recorded reliably. The following main groups of electronic devices and apparatus used for medical and biological purposes can be distinguished. So let's see. First type, devices for receiving or picking up, transferring and registering biomedical information. Such information can be not only about the processes occurring in the body, biological tissues, organs, systems of organs, but also about the state of the environment, sanitary and hygienic purposes, about the processes taking place in processes and etc. So, for the overwhelming majority of these devices in ratio engineering, the presence of amplifiers of electrical signal is characteristic. This group also includes electromedical equipment for laboratory research. For example, maybe pH meter. In laboratories, and using pH meter, we can detect the pH of our matter, or our liquid, or other matter. So, second type is electronic devices that provide a dosing effect on the body with various physical factors, maybe ultrasound, electric current, electromagnetic field, and etc., for the purpose of treatment. Microwave therapy devices, which we can use in physiotherapy, electrosurgery devices, which we can use in surgery, not we, doctors can use, pacemakers, and other devices. From a physical point of view, these devices are generators of various electrical signals. So, last type is cybernetic electronic devices. Maybe some points of this. Maybe electronic computers for processing, storage, and automatic analysis of biomedical information. Second part, devices for managing life processes and automatic regulation of the state of the environment around the person. Last part, electronic models of biological processes and etc. especially. So, the use of electronic medical devices and devices increases the efficiency of diagnostics and treatment and increases the productivity of medical personnel. So, entire arsenal of technical means used in medicine can be divided into the following groups. We can divide it into 4 groups. Let's see these groups on the slide. There are 4 groups. Let's start from the first. First group is medical devices, technical devices intended for diagnostic and therapeutic measurements. Devices for measuring biopotentials. About biopotentials we said earlier on our lecture and practice lessons. Electrothermometers we can use for measure the temperature of human, especially distant measurement. Without contact. It's very necessary for us with, if we can say about COVID-19. And what else? Electromanometers, when we can measure the arterial pressure, for example. Spectrophotometers we can use in laboratory studying, when we want to understand the composition of liquid, for example, using spectrophotometers, oximeters, rheoplethysmographs, and other devices. What is the second group? Medical devices and system. A medical device is a technical device that allows you to create an energetic effect of therapeutic or destructive properties, as well as to provide for medical purposes a certain composition of various substances. Maybe devices for direct current therapy, devices for therapy with pulsed and alternating current, devices for low frequency and high frequency therapy, ultrasound devices. All these devices are used in physiotherapy, especially for sportsmen, and not only for sportsmen, for different patients too. We can use, doctor, we can come to doctor, physiotherapist, and it can recommend us to do this procedure using these devices, for example, high frequency therapy, if, for example, we have problems with our ears, maybe. When we have problems with our ears, we have a eel in our ears, and we can, doctor can treat us using physiotherapeutic methods like as a high frequency therapy. And these types of therapy, devices for the life support of the body. The term medical device is an umbrella term for medical devices and apparatus. So, next group is medical instruments, different medical instruments which we can use in surgery, for example, therapy, for example, for diagnostic methods and and medical equipments. So, the main requirements for medical equipment may be electrical safety, firstly, secondly, reliability, and measurement accuracy. We must not forget about these 3 points of medical equipment. So, one of the most important tasks in the development, industrial production, and operation of electromedical equipment is to ensure complete electrical safety for service personnel and patients. So, an electric shock to the body can be in the form of electrical injury or electric shock. Electrical injuries are the result of external local action of current on the body. Maybe let's see the types on the slide. Maybe electrical burns, electrometallization of the skin, and current signs. What is about electrical burns? Let's see. First type of electrical injury. What is this? Electrical burns are either a consequence of the thermal action of a current passing through the human body, or occur under the action of an electric arc, which usually occurs during short circuit in installations with a voltage higher than 100 volts. Electric signs of current, skin lesions in the form of sharply outlined rounded spots, arise at the points of entry and exit of current from the body with close contact with live parts. Electric shock is the excitation of body tissues, and we can see, let's see about electric burns. Yeah, when we say about electric burns, the voltage is very low for electric burns. For example, if we say about the most number of voltage, if we say about electromagnetization of the skin, this is a type of problem when penetration of the smallest particles of molten metal into the skin under the influence of current, yeah, under the influence of current. So the small parts of metal can go through the skin, and we can see the result of it. Very bad process for our body, and have many people may have problems after this, yeah, and treatment after this problem, for example. And current science, and it's very not as the most problem, yeah, it's the smallest problem from like as electrical if we say about electrical injury, yeah, it's current science. How I said that the skin lesions in the form of sharply outlined rounded spots at the point of entry and exit of current from the body with close contact with live parts. It was electrical injury, yeah, types of electrical injuries. What is about electric shock? Electric shock is the excitation of body tissues under the action of a current, which is accompanied by an involuntary convulsive muscle contraction. So electric shocks can cause the most severe injuries affecting the internal organs of a person. Lungs, heart, central nervous system, yeah, especially the main parts of our body, our organs. As a result of an electric shock, maybe cardiac activity can occur. Rhythm disturbance, ventricular fibrillation, respiratory distress, shock in especially severe cases leading to this. Really, electric shock, it's very dangerous type of damage to our body, yeah? Because we must be safety with the electrical devices. Not only medical electric devices. We can use accuracy our devices in the kitchen, especially girls must know about it. Yeah, please be careful with electrical devices, with telephones, with computers too, because problems may be and with these devices too. Not only big medical devices, maybe problems with telephones, maybe problems with computers, simple devices which we use in our life for studying, for cooking, and other types. So let's continue. And the effect of an electric current on the body depends on a large number of different factors. Yeah, we know that effect of electric current, maybe types of electrical injury or electric shock, it connects or it depends on a large number of different factors. So the main of which are magnitude of the current, determined by voltage and body resistance applied to the body, the type and frequency of the current, the duration of exposure, the path of the current. The patient, due to various reasons, for example, weakening of the body, the effect of anesthesia, a lack of consciousness, the presence of electrodes on the body, that is, direct inclusion of the patient in an electrical circuit, and etc., finds himself in especially electrically hazardous conditions in comparison with a healthy person. Medical personnel working with medical electronic equipment are also at risk of electric shock, really. An electrical voltage is usually set in an electrical network and in technical devices, but an electric current acts on the body or organs, that is a charge flowing through the biological object per unit of time. So electrical charge goes through our body and go is per unit of time. So the magnitude of the current is the main parameter that determines the degree of damage. So when you squeeze the electrodes with your hands, sensation of a current with a frequency of 50-60 Hz appear at a current of about 1 milliampere with an increase. So it's sensation of current. 1 milliampere, it's sensation. We can sense the current. Only sensation. So these numbers, these safety numbers doctor can use these safety numbers near 1 milliampere, maybe 2 milliampere in physiotherapy, especially in electrophoresis types. So what will be if we can increase the number of current? So if current will be from 5 to 10 milliamperes, cramps begin in the hands. If we increase more, for example, a current of 12-15 milliamperes, it's already difficult to break away from the electrodes, for example, or difficult to come off the electrodes if the patient take the electrodes. So at numbers from 50 to 80 milliamperes, respiratory paralysis occurs. And if the number of current will be 90 or 100 milliampere, what happened? A duration exposure of 3 seconds or more, cardiac paralysis may be or heart failure. If we can act the number of current 100 milliampere till only 3 seconds on patient, maybe heart failure. So students, you don't forget about these numbers. Really, it's very necessary for your practice and for your safety at home too. So, under the action of a direct current, the corresponding reactions take place at the moment of closing and opening the circuit and occur at a much greater value. So, the sensation of a constant current appears at 5-10 milliamperes, difficulty breathing, and 50-80 milliamperes, respiratory paralysis at 90-100 milliamperes. So the most important for the outcome of an accident in this is the time of action of the electric current on the body. With a decrease in the time of action, the threshold current increases, which doesn't cause paralysis or fibrillation of the heart. The resistance of human body between two touches to electrodes consists of the resistance of internal tissues and organs and the resistance of the skin. The resistance of the internal parts of the body for the parts palm, foot, is 1 kilo ohm. The resistance of the skin depends on internal and external reasons and is an order of magnitude higher. So, it was information about effect of electric current of the body. Let's now move on to discussing medical devices in more detail, especially about medical electronics. And any biomedical research is associated with the receipt and registration of relevant information. Despite the variety of devices and methods used for this purpose, you can indicate their general schemes and principle of operation. In order to obtain and record information about the state and parameters of a biomedical system, it's necessary to have a whole set of devices. Let us consider the general scheme for obtaining and registering biological information. You can see this scheme on the slide, big scheme. So, this scheme is general and reflects all kinds of real systems used in medicine for diagnosis and research. In medical electronics devices, the sensing element either directly generates an electrical signal or changes such a signal under the influence of a biological system. The primary element of this set is sensitive element of the measuring instrument called the pickup device. Firstly, certainly contacts or interacts with the system itself. The rest of the elements are usually located separately from the biomedical system. In some cases, parts of the measuring system can even be carried at considerable distances from the object of measurement. Thus, the pickup device converts the information of biomedical and physiological content into a signal of an electronic device, because electronic devices can't understand the language of our body, the language of potentials, for example. Our electronic devices can understand only electronic language. So, there are two types of pickup devices used in medical electronics, removal devices. This is electrode or sensor, maybe. The final element of the measuring chain in medical electronics is a measuring instrument that displays or registers information about biological system in a form accessible for direct perception by an observer. In many cases, there are elements between the pickup devices and the measuring device that amplify the initial signal and transmit it over a distance. In the block diagram in the figure, X value means some measurable parameters of a biological system, for example, blood pressure, temperature, pulse wave, and other. And outside, the Y letter denotes the output quantity. For example, the current may be milliamperes on measuring device, or the displacement of the written in millimeters on the paper of the recording device. To obtain quantitative information about biological system, the dependence Y is f from x must be known. Now, let's look at each element of this block diagram in detail. Firstly, especially, we can take the information from the biological object, Firstly must be biological object, and we put the electrodes and sensors on biological object, and after that use the medical device, for diagnosing, for example. Especially, first part is biological object, maybe our body, maybe animal's body, and other types. After that will be electrodes or sensors. Let's start from electrodes. So, in medical practice, electrodes and sensors too are most often used to obtain biological information about a patient. Really, there are many types of devices which we can use for detect or for take information from the body, for example. Electrodes are specially shaped conductors that connect the measuring circuit to the biological system. They receive, so they take, receive, and transmit information in an unchanged form. In diagnostics, electrodes are used not only to pick up an electrical signal, but also to supply an external electromagnetic effect, for example, in radiography. In medicine, electrodes are also used to provide electromagnetic effect for the purpose of treatment and during electrical stimulation. According to their purpose, electrodes for picking up a bioelectrical signal are divided into following groups. And before it again says that electrodes is a simple device that can receive, take the information from body and transmit this information in unchanged form. What type take? The same type go out from electrode to amplifier, yeah? To the second part is amplifier. After electrode go to amplifier. So without changing, only take and give, only take and give. So now let's see the classification, yeah, of electrodes. The first group is for short-term use in functional diagnostics rooms. For example, for one-time recording of an electrocardiogram. For example, yeah, we can use these short-term electrodes for electrocardiography when we can recognize the statement about our cardiovascular system in the heart, not cardiovascular system, not only cardiovascular system, especially we can detect the problems with conductive system of our heart, yeah? How electrical signal go through our atypical myocardial cells, yeah? We said about it on the lecture about biopotentials, yeah? About biopotentials, about calcium channels, potassium channels, yeah, sodium channels, yeah, which can work in our heart in atypical myocardial cells. And according to this, electrical signal action potential can go through these atypical myocardial cells and after that give energy to typical myocardial cells, and after that we can see the contract of our heart. And using short-term electrodes, yeah, in functional diagnostics, we can detect, we can recognize, and we can see on the paper or in the computer, for example, we can see the problems, we can see how the electrical signal, how the action potentials go through the conductive system of our heart, so through the atypical myocardial cells. And after that, we can say our patient has he problems or no. It's very necessary for us, and we must understand that this is very simple electrodes we can use, yeah? So the next part is for long-term use. For example, with constant monitoring of seriously ill patients in intensive care units. Especially, yeah, if we say about intensive care units nowadays, we must not forget about COVID-19, yeah. So this infection this virus is very dangerous for us, yeah, and we know that many people can be in intensive care units and don't can exhalation and inhalation, without the special device, really. And for doctors, doctors must know and must recognize the problems with the inhalation and exhalation, for example, and for this we must use the long-term electrodes, for constant monitoring, of heartbeat, of inhalation and exhalation, and other temperature, especially temperature, and other problems. And really, it's not connect with only COVID-19, maybe other problems when, for example, after surgery, patient may be in intensive care units, and doctors must recognize problems using the special electrodes. And the main idea of these electrodes that they must be safety for patient, and they must and we must use it for long term. So the next type of electrodes is for use on mobile subjects, for example, in sports or space medicine. Especially sportsmen is special part of people, I think, special group of people, because sportsmen, is sport for us is a very, very necessary part, but professional sports is it's not near for us, is really far from us, but we know about it, and we really we must know our sportsmen, and they have many train of this from this body, and for example, for monitoring processes, for example, of heart beating, inhalation, exhalation, resistance of body, muscles contracts, problems, doctor can use a special mobile subjects, when we can use it, when patient or sportsman are going, for example, going a train, or maybe running, jumping, and other type, for best understanding the problem, if it may be so. So the last classification is electrodes for emergency use, such as in ambulance. It's clear that in all cases their own specificity of the use of electrodes will appear. Certain requirements are imposed on the electrodes. They must be quickly fixed and removed, have high stability of electrical parameters, be durable, don't interfere, don't irritate biological tissues, and etc. An important physical problem related to electrodes for picking up a bioelectric signal is to minimize loss of useful information, especially at the electrode skin contact resistance. Due to the presence of resistance, we understand that information comes to the signal amplifier in a modified, reduced form. To reduce the electrode skin contact resistance, they try to increase the conductivity of the medium between the electrode and the skin. Use gauze wipes moistened with saline or electrically conductive pasts. You can reduce this resistance by increasing the electrode skin contact area, increasing the size of the electrode, but the electrode will capture several equipotential surfaces, and the true picture of the electric field will be distorted. So, the size and type of electrode used also play an important role in determining its resistance. Larger electrodes usually have a lower resistance. Surface electrodes have a resistance of 2000 10,000 ohms. And small needle electrodes have a much higher resistance. From the above, the following conclusion can be drawn. For high quality registration of biopotentials, the following conditions are necessary. What conditions? First is low contact resistance between electrode and skin. Next is low inter-electrode resistance. And last, a low level of electrode potentials arising on the surface of the electrode at the point of contact with the skin surface. And to remove electrocardiograms, electrodes are attached to the limbs with a special rubber bands, metal plates with terminals, into which the pins of the lead cables are inserted and fixed. Cables contact and electrodes to the electrocardiograph. A chest electrodes, about chest electrodes we said on biopotentials, lecture 2, is placed on the patient's chest. Here we have simple 6 electrodes, and it's necessary maybe use the V7, V8 and V9 on the continue on the same line. So it's held in place by a rubber suction up. This electrode also has a pin terminal for the lead cable. And we know that many biomedical characteristics can't be directly removed by electrodes. Since these characteristics are not reflected by a bioelectric signal, maybe blood pressure, maybe temperature, heart sounds, and many others. So really, it's not electrical signal. What is about blood pressure? This is the pressure, temperature in degrees, and for example, heart sounds, really sounds, and other. In some cases, biomedical information is associated with an electrical signal, but it's more convenient to approach it as a non-electrical quantity. For example, the pulse maybe, pulse wave. In these cases, sensors, measuring transducers, are used, not electrodes. We must use the sensors for these types. So, what is about the sensor? What is this? This is a device that receives, convert a measured or monitored value into a signal convenient for transmission, further conversion or registration, and transmits biomedical information. So, what is the difference from electrode? We said that electrode is the device which can take the information and give it, without changing, without changing. We said about it earlier when we said about electrodes. And what is about sensors? Sensors can take information, really, too. For example, it receive the information. After that, it can convert the measured value in what? Into a signal, convenient for transmission. And after that, it transmits this biological maybe information. So the difference between sensors and electrodes is conversion. Sensors can convert information and do it, but electrodes can't convert the information. They only can receive and transmit information in unchanged form. And sensors receive, convert, and transmit biological, biomedical information. So, the sensors to which the measured value is connected, so the first in the measuring chain is called primary. Within the framework of medical electronics, only those sensors are considered that convert a measured or monitored non-electrical quantity into an electrical signal. The use of electrical signal is preferable to others, since electronic devices make it relatively easy to amplify them, transmit them over a distance, and register them. Sensors are subdivided into generator and parametric. Generator sensors and parametric sensors. So what is about generator sensors? Generator sensors directly generate voltage or generate current under the influence of the measured signal. Let us indicate some types of these sensors and the phenomena on which they are based. Firstly, maybe based on piezoelectric effect. The second is thermoelectric. Thermoelectricity is it's based on thermoelectricity. And what is about thermoelectricity? Thermoelectricity is the phenomenon of the emergence of an electromotive force in an electric circuit consisting of series connected dissimilar conditions with different temperature of junctions. So, next type is induction, and induction sensors based on electromagnetic induction. And next is photovoltaic, based on photoelectric effect. And let's see about parameter sensors. What is it? Parametric sensors, under the influence of the measured signal, change any of their parameters. So, what types maybe? And before we will indicate some types of these sensors and parameters measure with their help. Firstly is capacitive, capacity. Rheostat, based on ohmic resistance. Inductive, based on inductance or mutual inductance. Depending on the type of energy that is carry of information, there are mechanical, acoustic, temperature, electrical, optical, and other sensors. If, for example, if we detect problems with eyes, optical, maybe with heart, other information, temperature devices, and other. In some cases, the sensors are named according to the measured value. For example, a pressure sensor, a strain gauge sensor for measuring displacement or deformation, and etc. So, now information about the characteristics of sensors, metrological parameters of sensors. The sensor is characterized by a conversion function. The functional dependence of the output quantity, Y, on the input quantity, X. We can see. Which is described by the analytical expression. Y is f from x. Or a graph. A graph is straight line of this function. So, the simplest and most convenient case is directly proportional dependence. Y is kx. There are special characteristics of sensors that describe their main parameters. Let's see on this. The sensitivity of the sensor. This parameter shows the extent to which the output value responds to a change in the input value. It's the ratio of change in output value to the change in the input value. Depending on the type of sensors, it's expressed, for example, in ohm per millimeters, ohm divided by millimeter, in millivolt divided by Kelvin, yeah, and etc. The timing characteristics of the sensors are essential. The fact is that physical processes in sensors don't occur instantly. This leads to a delay in the change in the output value compared to the change in the input value. This describes the inertia of the sensor to us. What is about it? The inertia of the sensors is estimated by its transient characteristic, which expresses the change in the output value over time with a jump like change in the converted value at the input, proportional to the mass of the sensor. Proportional to the mass of the sensor. The design of sensors used in medicine is very diverse, from the simplest, such as the thermocouple, to complex Doppler sensors. About Doppler effect, about Doppler sensors. We said in bioacoustic information, we said it about Doppler effect in medicine, how can we use the Doppler effect, and what can we detect in our vessels using Doppler effect, the direction of blood going, what else, the type of liquid going, maybe laminar or turbulent flow, the type of flow, and other different information. So sensors are technical analogs or receptors in biological systems. So the next element, if we see again on the scheme, and the next element after electrode or sensor is the amplifier. Electronic amplifier. So, but what do we need the amplifiers for? This is one important note. All bioelectric signals from our body are very, very, very weak. I think you know this. We said about it on the lecture about biopotentials. The smallest number, minus 95 millivolts, minus 65 millivolts, and other the smallest number. So, to make it more convenient for us to process and describe the information received without errors, the signal must be amplified. For this, amplifiers are included in many medical electronic devices. They are used to increase the amplitude of weak signals in system that record biomedical information. An amplifier of electrical signals, or we can say electronic amplifier, is a device that increases these signals without significantly changing their shape. Depending on the purpose, amplifiers differ in voltage, amperage, and power. In the following, all definitions and conclusions with refer to the voltage amplifier. The functional diagram of such amplifier is shown in the figure. The input voltage is supplied to input terminals of the amplifier. The electronic circuit of the amplifier provides an increase in its amplitude. Let's compare amplitude before amplifier and after amplifier. So the electronic circuit of the amplifier provides an increase in its amplitude due to electric power supplied from an external source. The amplifier signal, output signal, is removed from the output terminals. The amplifier can be made as a separate unit or be part of a medical device. In the latter case, the signal from the sensor goes to the amplifier. The amplified signal is fed to a device that converts the electrical signal to a form suitable for display and then to an information display device. For example, a liquid crystal display of our computers maybe. So now let's look at the characteristics of amplifier. Metrological parameters of amplifier like as a sensors, like as we saw earlier about sensors. So any periodic signal can be represented as a sum of sinusoidal signals, the frequencies of which are multiples of its frequency. For this reason, all properties of amplifier are studied for harmonic signals with different frequencies and amplitudes. So, the most important characteristics of an amplifier are the gain and bandwidth. The quantification of the amplification effect itself is the amplification factor. The gain is equal to the ratio of the amplitude of the output signal to the amplitude of the input harmonic signal. You can see the formula on the slide. The gain is the K letter. We should put letter K for the gain, and we should divide output signal amplitude by input signal amplitude, and after that we can calculate the gain of our amplifier. So this value is determined from the experimental amplitude characteristics of the amplifier. What is about amplitude characteristic of the amplifier? Amplitude characteristic of the amplifier is the dependence of the amplitude of output signal on the amplitude of the input harmonic signal. To keep the waveform constant, the gain must be the same over the range of possible input signal amplitudes. This requirement is met by the linear section of the amplitude characteristic marked with a solid line. The gain is determined from the linear section. When amplifying a signal of a complex shape, its spectrum may contain harmonic whose amplitude go beyond the boundaries of the working section U1, U2. In this case, the shape of the output signal will differ from the shape of the input signal, so non-linear amplitude distortions will occur. Note that in the development of medical devices, the possible amplitudes of the input signals are usually known. Therefore, amplitude distortions are minimized by constructive methods. Amplifier includes reactive elements, maybe inductors and capacitors, whose resistance depends on frequency. Therefore, it depends on the frequency and the gain. This relationship is called the frequency response of the amplifier. Let's see on the definition about this point. The frequency response of the amplifier is a dependence Again, this is dependence too. Dependence of what? Dependence of the gain on the frequency of the harmonic signal. K is f from frequency. Due to the dependence of the gain on frequency, different harmonics in the spectrum of a complex signal are amplified in different ways, which leads to distortion of its shape. These distortions are called linear or frequency distortion. In ratio engineering, it's generally accepted that in the area where the gain is at least 0.7 of the maximum value, gain K is more than 0.7 multiplied on K max. Linear distortions are insignificant. Therefore, the frequency range from F1 to F2 is called the amplifier bandwidth. And let's see on the definition, what is this? The amplifier bandwidth is the frequency range in which linear distortion is significant when the gain K is more than 0.7 K max. The lower limit of the bandwidth is determined by the frequency of the biological process and can be appropriately chosen constructively. The situation with the upper limit is more complicated. Theoretically, the number of harmonics in the spectrum of a complex signal is infinite. Therefore, there will always be harmonics outside the bandwidth. So, linear distortion is theoretically irreparable. However, in practice, the amplitudes of the higher harmonics are so small that their loss does not matter. So, now let's discuss with you the features of amplification of bioelectric signals. Yeah? What features maybe? We have already understood with you that bioelectric signals are usually very small. So, an amplifier must be used to register them. Consider the amplification of a signal that is removed by electrodes from a biological object. The specificity of biopotential enhancers is determined by the characteristics of biopotentials. Firstly, biopotentials must be what? Biopotentials are slowly changing signals. Yeah, they regulate so. And we must use the special devices when we know about it and create the device according to this point. So, amplifier bandwidth should cover of all low frequencies. According to the first feature. What is the second? We know that biopotentials are weak signals. And according to this point, the amplification factor should be large enough. All of our biopotentials are very small and weak signals, and amplifier must amplificate the biopotentials according to the special amplification factor, and it should be large enough to recognize the biopotential, and analyze this biopotential after registration. And what is the last feature? The resistance of the biological system together with the resistance of the electrodes, as a rule, is high. We know that the resistance of our skin is high, really. Therefore, the amplifier must operate at low currents. The low frequency of the bioelectric signals necessitates of use of special amplifiers. I think you know about it. So, having discussed the initial participants in the scheme for picking up, processing and transmitting transmitting biomedical information, biological information, physiological information. We should not forget that, in essence, a large group of medical devices used in medicine are generators of various electromagnetic oscillations. What is about generators? Generators are special devices that convert the energy of constant voltage sources into the energy of electromagnetic waves of various shapes. Consider the classification of generators, which we can use, we can put in medicine and in other types. So, firstly, by the form of the signal, the generator of harmonic oscillations and the generator of oscillations of a special form, for example, impulse oscillations. What is the next? By the frequency of generated signals. By output power is next, yeah? And the last is according to the principle of operation, a self-excited generator and an external excited generator. Harmonic oscillations are self-oscillating systems with positive feedback, which is carried out using a transistor or triode. Oscillations of the required frequency are created by an oscillatory circuit, and energy comes from a constant voltage source through feedback. To generate non-harmonic oscillations, relaxation type generators are widely used, in which the processes of charging and discharging a capacitor are used. And let us now consider generators. Different generators that are used in medicine now, used in medicine earlier, and will used in medicine later. So, first type of generator is ampli-pulse therapy. First, ampli-pulse therapy. The special therapy, the special types of physiotherapy. What is this? The generator of the corresponding device creates sinusoidal currents at the frequency of 5,000 Hz, modulated in amplitude by a low frequency in the range of from 10 to 150 Hz. The choice of the fundamental frequency of 5,000 Hz is due to the fact that at this frequency the skin resistance is very small. This ensures good penetration of the current deep into the tissues, and after that we can act on a different part of our body, especially on the muscles, especially on the problems with our muscles maybe. So, what is the next? Next generator is fluctuation. The generator, what is this? Yeah, we must say. The generator of the corresponding apparatus creates a sinusoidal current of low strength and low voltage, randomly varying in amplitude and frequency within a range of 100 to 2000 Hz. The use of such currents reduces the likelihood of tissue habituation to the stimulus. What is the next type? Generators which we can use in medicine, which we can use in physiology especially. This is electrosleep. What is this? The generator of the corresponding apparatus create a pulsed current of low frequency and low strength with rectangular pulses. And really, we use electrosleep now to recognize problems with the brain, especially with the conducting, of conductive system or nervous system, when the signal, electrical signal, can go through our nervous into brain and characterized our potentials, really. Next is diadynamic therapy. What is this? The generator of the corresponding apparatus creates a current with a half sine pulses. It connects with our muscles. And electrical stimulation. Last part is electrical stimulation. What is this? The generator of the corresponding device creates impulse currents, in particular exponential impulses, to restore the function of the human neuromuscular system. Especially electrical stimulation may use the sport to the sportsmen. Doctors may use the electrical stimulation for the sportsmen's muscles. So, the final element of the technical scheme, let's see on the scheme again, if you forgot it. The after amplifier will be transmitter and receiver, so we can transmit the information, and receive the information, and after that, the information come to output measuring and recording device. Let's see. This device, that displays or records biomedical information. A display device is understood to mean a device that temporarily presents information. When new information appears, the old information disappears without a trace. These are, in particular, pointer instruments, ammeter, ampermeter, voltmeter, and etc. A pointer ampermeter, for example, shows the current strength at a given moment and does not record it. When the current in the circuit changes, the information about previous value is irretrievably lost. To memorize the information displayed by such devices, it's necessary to specifically record it, which, for example, is what students do in a physics laboratory, taking readings devices. Medical and biological applications of a display devices is quite small. Resistance electrothermometer, pulse frequency meter, and etc. Significantly more widespread in medical electronics are recording devices that record the information on any medium. This allows you to document, store, reuse, process, and analyze the received biomedical information. Displaying and recording devices are subdivided into analog, continuous, discrete, and combined, combining the capabilities of analog and discrete. Let us consider in more detail the analog recording devices, most common in the practice of biomedical research. Some of them are also called recorders. So, in medicine, biology, and physiology, of the following methods of recording information on a carrier are mainly used. Firstly, application of a layer of substance, colorant, for example, ink, pen, and jet systems. Change in the state of the carrier substance, for example, photoregistration, electrochemical, electrophotographic, xenophotography, and magnetic recording. And the last is the removal of the substance layer from the carrier. Smoked surface, thermal recording maybe. So maybe display devices and registration devices. Yeah, you can see the definitions of display devices here and registration devices. So this lecture was the last lecture of physics point, yeah, and on the next week we will start to talk about statistical information, yeah, about informatization in medicine, about and we will start from the interesting part. I think you know this part, you use this part in your schools maybe or colleges. We will say about different statistical information, really, not only physics. Yeah, we must know statistical information too. Statistical information especially, yeah, it's very, the interesting part is probability. We on the next lecture we will say about probability, definition of probability, the points of probabilities, types of probabilities, as using probability in medicine studying, really it's necessary for you. And after that we will talk about statistical information, yeah, statistical criteria, different statistical criteria, how can we use these statistical criteria in medicine, in studies especially. So today I can say you thank you for the attention and goodbye.